Analyze the polarity of the two molecules. Water, H2O, a highly polar molecule with a permanent dipole due to its bent geometry and the significant electronegativity difference between oxygen and hydrogen. Benzene, C6H6, a flat, highly symmetric hexagonal ring of carbon atoms with hydrogen atoms pointing outward. Because carbon and hydrogen have very similar electronegativities, and because the hexagonal ring is perfectly symmetrical, all individual bond dipoles cancel out, making benzene a nonpolar molecule. Determine the interactions between a polar and a nonpolar molecule. When a polar water molecule with a permanent dipole approaches a nonpolar benzene molecule, the electric field of the water molecule distorts the symmetric electron cloud of the benzene molecule. This temporarily induces a weak dipole in the benzene ring. The electrostatic attraction between water's permanent dipole and benzene's newly formed temporary dipole is called a dipole-induced dipole interaction. Identify other universal intermolecular forces. London dispersion forces, LDFs, arise from instantaneous fluctuations in electron density and are present between all molecules, whether they are polar or nonpolar. Thus, LDFs also contribute to the weak attraction between water and benzene. Relate these forces to solubility. Because the dipole-induced dipole and London dispersion attractions between water and benzene are much weaker than the highly favorable hydrogen bonds water molecules must break to make room for benzene. Benzene is only sparingly soluble in water. This points directly to option D. The correct answer is option D. There are dipole-induced dipole and London dispersion interactions between water and benzene.